Hello, welcome back to Windload Solutions. So in this video, what we're going to do is walk through the entries for wall openings, anything on a wall opening. So window, door, shutter, things of that nature. So we're going to take a look at an actual project. So here we have a project in Naples, Florida, and it's a window and door replacement. So if I go through what I have been provided here, right, is information, architectural sheets, and I have all the information that I need for this building. So it's a condo building here, and we can see that everything is labeled nicely. So we can go ahead and just verify everything at the mark ID for F, G, H, and so on. Okay, and then we also have some sliding glass doors, and you can see that here with the panel type and handling. What I would actually do is I would use this as the mark ID, so 4L, and then put these dimensions in. So we're going to take a look at this. Now, what I want to show, and there's a lot of questions sometimes that we get with this, is as far as dimensions, you will need to provide the dimensions of the entire building. So for example, if you are only doing one condo, just for example, and say you're replacing windows in one on the second floor, just this condo, you will still need to provide the dimensions of the overall structure or building or house, whatever it is that the condo is in. Okay, so you wouldn't do the dimensions just of your condo. It needs to be of the overall building itself. If you're doing the overall building itself, then it's obvious, but sometimes it's not that obvious if you're just focused in on, one particular thing that might be in a larger building. So just want to point that out. So now let's say that you are doing this on your computer. I've had this situation. I see that the scale is 3/16 equals 1 foot. Let's say I don't have a printout of this, and if I print it out, it's going to be a different scale, even if I have this architectural scale, right? So you would need to print this off full size to get that actual, to be able to use this scale. So, but what you can do, right, is if you go up here, you see where it says zoom, and it's at 57 right now. If I make sure that I put it at 100, then that's 100% the scale. So now what I can do is I can take, I can have this on my screen, and I can actually take the ruler that I have that's 3/16 inch equals a foot, and I can dimension that out. I can just put the ruler on the screen itself, for example. Now, if you don't have that, another thing that is really cool, and seems obvious, but what I found here is if you go to www.arc as an architecture, so arctoolbox.com, and you can follow this, take this whole address and write it down, copy it. It'll take you right to this page, but this is actually a printout. So if you print this out, it will be to scale, and then you can actually use this as your ruler, right? And so we see there's 1/16, 1/8. If I scroll down, here's the one with the 3/16 scale. So if you need that, again, you could print this off, use this as your scale. You can fold it. These are the folding lines. It's pretty cool. And just use that. I've actually done that. It works really well. So again, print this off, make your ruler, put your screen up to 100%, and then measure away, and then you can get the overall dimensions of your building. Now, in the same instance though, I didn't have the roof height, because if I scroll down, I have these details and notes, but there wasn't a reference for the height of the building itself. So in this case, you need to call whomever it is that you're working on the project with, or the architect that's doing this work, and they will have this information. Okay, so that's just a little side note that I think is helpful. Now, let's get into the program. So this is the overall project, just as the zoomed out portion. So just to show you here, general information here at the top, building information, which is your length and width, and if it's lifted above the ground or not. Frequency information, so I wouldn't mess with this unless you know these numbers. These are the standards or typical, but they are editable if you want to do that. Roof information, you'll see that not everything is highlighted in yellow here. Previous versions maybe we did have roof information, but if you're not doing a roof, you don't need to have the roof type. You don't need the roof ridge or eave. You don't need any of that information. But what you do need for all windows, doors, roofs, or windows, doors, shutters, anything in the wall openings, what you do need to have is the mean roof height. That is required. So what we found for this one is it's actually 30 feet. So I'm going to type that in, and then the topo information, it's flat, but if you have anything else, and you could go down here to the diagram and see, it'll give you the dimensions. So if you have something that falls in this kind of category where you need to provide this information, everything is provided here. You can use these as your dimensions for all of these entries. Notes are here. Anything in the red, something red here in the top right corner is a note that you can just hover over, give you a little information, right? Instead of having to go back and forth through the entire book. Project information. So if your client address name, this isn't going to actually impact anything right on the calculations, but it's good to have. Keep track of the address, especially if you're submitting this for permitting. Have the address here. You'll probably want to put your project number. Computations, these are automatic. Everything here is automatically calculated based off the information that's entered. And then down below are your entries for your actual windows, doors, etc. So you'll put in your marker ID here on the left if you have one or want it. Description here, but what is required is a zone, a width, and a length, and then everything else will print out in this section here for your wind load pressures. And then we have product approval. So your NOA approval, things like this, you're free to type in whatever you need here, the manufacturer name, model number, so you can get these positive, negative pressures that this particular product that you're purchasing has, right? So if it's whatever positive, negative pressure, you'd probably put that here according to that particular window door that you are purchasing, okay? And it would fall under this mark ID, right? So for example, let's do, so if we were to do F, right, then we know that F is going to be a certain type of window per our product details, and we'll know if it meets the criteria. But what we first need to do is we need to be sure the location that we're at, what wind loads are actually required. So let's zoom in now, okay? And I'm going to zoom in to the top. And we're going to go through this together here. So the wind, design wind speed. So what this is if you click in here, you get a pull down and you have either nominal or ultimate. Just so you know, ultimate is the default that you should always use. Nominal is, I would say, in special cases. It's going to have a 40% reduction on all wind load pressures that are calculated. So if you scroll down to the bottom, you'll see that it filled in ultimate wind load pressures. If I hit nominal, it's going to change to nominal, because these pressures down here is what's going to get impacted or change. And throughout all of these other entries, you're not going to do anything in regards to nominal. Nominal is a calculation. Ultimate is the actual pressure that you're going to read off of velocity map. So any kind of velocity maps that you look at in the book or wherever, it's always ultimate. It's never nominal. Nominal is a calculation. It's a reduction. And through the program, if you have it for nominal or vice versa, all you need to do is toggle back and forth and it'll automatically calculate for you. But let's go ahead and use ultimate because that's what we do need. Now we have a wind speed. Okay, well, what is that? We don't know. So in a program, what we have here is that you can just click here. And so when you click this, it's going to take you to a page on our website. And we're going to scroll down and we're going to close this box out. And then we're going to paste the address in here. Okay, and then hit search. And then the risk, we are in a residential area. So that's always in a risk 2 category. There's 4 different types of risks, and you should check those out. But they basically correlate with risk being the number of people that could be injured or a fatality if there were a worst case scenario. So the more people you have, like so a category 4, for example, would be like a stadium or a church or something where there's a lot of people. So if the whole building got wiped out, there is the risk that a lot of people could be injured or killed, and that's what we don't want to have. So if you fall in that category, then that's what you'll need to select, right? But we are in a residential area. It's just a family home. It's a condo. There are a lot of people around, but they're all individual condos. It's nothing where people are congregating, right? So anyway, a suburban kind of atmosphere always is, again, a 2. And then all you need to do is check wind. There's other selections, but we don't need it for this. And leave the soil class as default. We are using the 722. You can use other versions if you want, but we are using the ASCE 722, which is what is required by law, especially in the state of Florida, but you need to verify with your latest state building code and what it references, and that's what's going to dictate that. Okay, so for Florida, in this case, since we're in Naples, Florida, it is required by law to use this ASCE 722, which is the most recent publication at this time. All you do is click view results, and that's it, and then you get your wind speed, 163. Something I want to point out though, in Naples, they do have their own website, and this could change or vary. What you need to do if you're in that area is there's this website here, and if your state or county has its own, then you're going to want to verify it with that. But as far as I know, what we just showed with ASCE and what's on our website is it is what is used everywhere, okay, across the United States. But Collier County in particular has its own. So Collier County gmd.maps.arcgis.com home index HTML. So you can go there and type that in. You can go then to addressing is where you'd want to go. Once you get into here, I agree, okay. Here are the locations. You put your address in here and you go through the same kind of process. I think the site might be down at the moment because it should give you something similar to what we looked at here, where it pops out the velocity. But that is where you would go. That is what you would do. There's some directions too if you want. You see these categories, risk category 1, 2, 3, 4. It's defaulted to 2, which is what you want, but which is like these are associated with the risks. So we had a risk category 2. So this would be a risk category 1, risk category 2, 3, 4. That's what this is. Okay, so just to let you know how that works. Now let's go back to the program. All right, so we know that we need a 163. I think when it's working, the Collier map, it actually might be 164. In any case, we'll use this, and the exposure category A has not existed for years. It did prior, like let's say 1995 or before, but BCD is really what is being used today. D is if you're right on the water, or within a distance that is less than or equal to 5,000. So if you're in that range, basically a mile from the shoreline, then you are going to use D. If you're further inland than a mile, then just rule of thumb, I say mile, 5,000 feet. So if you're inland a little more, then you're going to use B. B is for urban suburban areas, and that's where we're at. If you don't have anything around you, then if B and D are not used, then C is what is the default. Okay. Sometimes that can get a little tricky, but you can always check with the permit department as well. But go ahead and read these notes, make sure how they apply to your location, and then you'll be sure that you have everything accurate. Okay. But this is going to fall, it's further than a mile. It's in a residential area, so we're going to do a B. Now the enclosure classification here, you have all these options. You can do partially enclosed, enclosed, open building, partially open. So depending upon what these are, okay, is what you're going to want to choose. Here, different criteria for each of those cases, and then this is just some information about each one and which one you may need. So typically though, enclosed is what is used because it's there are no open walls. If it's not enclosed, then it means that you at least have one wall that's open. Okay, now open a building, what would that be? I like to think of it like more like a picnic area where you have a roof and there's pillars, but there are no walls, just for example. But this is enclosed, obviously. This is height above ground, so this is if it's actually raised off the ground, like water, air, whatever can pass through the bottom of the floor of the building. We are on the ground, so you can put 0 for meaning it's on the ground, or you can just leave it blank. Now the width and length, what we needed to do was actually needed to do those measurements off of the screen, and using that ruler is what I did before. And but for this building, what it came out to be is 101.5 feet by 73.5. And then we're going to leave this alone. We don't need to put anything here because we're doing windows and doors, but we do need that mean roof height. So that's it. And now we're all done. Let's scroll over. I'm not going to put anything here. You put whatever information that you may need there. Now all this information has automatically been calculated for you. So the most important one of them all, I would say, in order to fill out the rest of this sheet, is the edge strip, or the value of A. So that is 7.35 feet. And so what that means is the value of A are always the corner zone. So it always measures from the corner to measuring inward. And so if you were, let me pull up this drawing, just maybe give a little more clarity. So we're going to look at F. So F needs to be measured from the corner of the building. If we measure in, is it 7? If the 7 feet comes even near this section of the window, okay, if we touch the window, or if it's just in here just a little bit, that will be a zone 5, right? So 7.35 comes in, actually does come in here, right? It actually comes in closer, even hits the G. So all of these would be a 5. Okay, now let's zoom out. Let me scroll down, and you see these I, J, K. So these are more in. So if I measure 7.5 or 7.35 from the corner and go up, then it's further away, actually. So that will be a 4. But if this was right here on the corner and fell within that 7.35 feet dimension, measured from the corner in, and if it was over here, it'd be the same thing, measured from the corner over. Then if it was by the corner, again, in that range of the corner to the edge of 7.35 feet, then it's going to be a zone 5, right? So let's go down and we're going to start filling this out. So let's just do a couple here. Don't need to do the whole thing, just want to show how this works. So we're going to do F, G, and H. Okay, so F is a single hung window. and then we have a fixed window, and then H is also a fixed window. The zone measured in that we just saw is a 5. So we can type in 5 or 4, or there's a pull down. We can pick it. And this one was a 4, right? Because it was measured more in. Now all we need to do, now what pops up here, even though you haven't put in dimensions, this is just narrowing things down. But once you put in actual dimensions, it will give you exactly what you need. So we have, this is in inches, by the way. This is in pounds per square feet. This is in square feet. A lot of things are in feet, but the dimensions of the openings, the windows or doors or shutters, are actually in inches. The reason for that is just to make it easier on you as the user, because when you look up any kind of window door references, they're always in inches. Okay, but if you do need to convert anything, you can it's Excel, right? So I can hit equals, and you see the equals at the top, and you can just, do your math this way. Okay, so what we're gonna do here though, this is 18 inches by 61.5. And then it does the effective wind area and then your positive negative pressure. Let's do the next one. Let's do, it's 52 by same. Okay, and that adjusted. Now let's do the next one. 53 inches by 63 inches, and that adjusted. And now there's your pressures for these 3 windows, right? And then you have everything that you need. Now what you can do is you can just hit Control P or go to print it, and it'll print it in this format for you. Okay, and we have a black and white version as well. You can use, if you use AutoCAD, want to paste it into AutoCAD. A lot of people do that since a lot of their drawings are and schedules and everything are on CAD, and the colors sometimes don't show so great on CAD, but you can use the white and black version and everything will come out perfect. Okay, all right, that's it. That's all you need to do to obtain your positive negative pressures for windows, doors, or shutters, or anything that's on a wall, opening on a wall. Okay, and if there's any other questions, feel free to reach out. We're more than happy to help you. Thanks.